This is one of our funnest demonstrations to show atomic spectra. I'm going to show the spectrum of an incandescent bulb, which is continuous. And then I'm going to show the spectra of 4 different elements: mercury, nitrogen, neon, and especially hydrogen. Hydrogen will be important in the labs and in many other applications. So to show a spectrum, what we use is called a diffraction grating. This looks like a piece of clear plastic, but it's not. It is actually a piece of clear plastic on which an image has been inscribed with dark line, clear line, dark line, clear line, with about 10 to 13,000 lines per inch. So it's called a grating, just like a street grate. It has lines through it. And this allows you to resolve the spectrum of a source of light in the same way that a prism will resolve a spectrum. So what we're going to do is to place this diffraction grating in front of a camera and show you the view of this continuous source with the diffraction grating in place. And what you'll see in the image is the image of the incandescent bulb itself, and then to the right and to the left you'll see a rainbow spectrum that shows what wavelengths are present in this. And you'll see, as you look on the right side, violet through all the colors of the spectrum all the way through red. So that's a continuous spectrum. We'll try next to look at a discrete spectrum of mercury. Now what this is it's a discharge tube. It has mercury in it, and what I'll do is energize this tube, apply a voltage to the tube, and that causes the gas in it to emit spectral lines according to the spectrum of the element that we're using, in this case mercury. So I'm going to locate this, its proper spot, turn off the continuous spectrum. So this is a mercury spectrum without the diffraction grating. And let me get it in focus here. It's a bluish colored spectrum. There are mercury vapor lights that are used as street lights. So this may look similar to this bluish tint to the mercury vapor. Now let's try it with the diffraction grating in place. And what you see in this case are a green line and a blue line predominantly in this mercury spectrum. Next we will try a nitrogen spectrum. I'm using this fur to prevent burning flesh. So this is nitrogen spectrum. And with the diffraction grating in place, we see a number of lines present, some red, orange, yellow, green, and a violet turquoise-ish colored line. That's nitrogen. 2 more. This is neon. There's a beautiful orange look to it, and when the diffraction grating is in place, you see a large number of red and orange lines. This is exactly what's used for neon lights. The original neon light was made out of neon like this. There are other gases that are used to form signs, but neon was really where it started off. It has a beautiful, bright, reddish-orange spectrum. So So this is hydrogen. It has a reddish cast to it. And when the diffraction grating is in place, you'll see three lines. The farthest from the central image is a red line. That's the hydrogen alpha line. And it is very important in star images. A lot of nebula in the sky have hydrogen alpha line as one of their prominent spectral lines. Then there's a turquoise colored line. Greenish blue is the hydrogen beta line, both from the Balmer series, and we'll talk about those, or have talked about those in class. And then finally, the hydrogen gamma line is a violet line, is generally considered to be the one that's, those three lines are visible in the hydrogen spectrum. Those lines are associated with transitions of the electron in the hydrogen atom from a higher state to a lower state. In this case, the second energy level is the final state, and then higher energy levels, it starts from a higher level and goes down to the second energy level to get the Balmer spectrum. That is continuous and emission spectrum.